Okay friends, welcome to my YouTube channel Supply. So my name is Nithan and today I'm trying to present my video in English. Today I'm teaching you how to find the solutions of differential equations having constant coefficients. That means the coefficients of the differential equation will be numbers like 1, 2, 3. So how do we find the solution of a differential equation that has constant coefficient? So friends, it's the easiest way. So we only have to learn one equation, that is lambda is equal to minus a plus or minus root of a square minus 4b by 2. So this equation may sound familiar to you because there is also another equation, minus b plus or minus root of b square minus 4ac by 2a, which we learned like in 10th or something. So this equation is similar to that equation. So here, lambda is equal to minus a plus or minus root of a square minus 4b by 2. So, what is lambda, what is a, what is b? So, we have to find what is a, what is b, what is lambda. So, when we get a differential equation with constant coefficient like y double dash plus 2y dash minus y is equal to 0. So, when we get this equation like a constant, 1, minus 1, 2, these are all constants in this differential equation. So what do we do to find the solution of this differential equation? So we apply this equation. So we have to understand what is a, what is b and what is lambda. We convert this differential equation into a characteristic equation. So what is a characteristic equation? The general format of characteristic equation is lambda square plus a lambda plus b is equal to 0. So what is a and what is b? So what is a and what is b? A is the coefficient of the term y dash, which means in here the a is equal to 2, and b is the coefficient of y term, which means here b is equal to minus 1. So let's write a is equal to 2 and b is equal to minus 1. So we have our a and we have our b. So in here we have three types of general solutions for Here we have three types of general solution for applying this equation. So it all depends on what comes within this field. So a square minus 4b defines what kind of general solution the differential equation gets. So the a square minus 4b term defines what kind of general solution an equation gets. So if the a square minus 4b term is greater than 0, we have distinct real roots, which means we have two values for lambda, which is lambda 1 and lambda 2. Then our general solution will be y is equal to c1 e raised to lambda 1x plus c2 e raised to lambda 2x. So if the value of a square minus 4b is equal to 0, we have real double roots, which means the general solution of the differential equation will become y is equal to c1x plus c2 into e raised to lambda x, which means we only have one value for lambda. But when the a square minus 4b term becomes negative, which means it becomes less than 0, we have two complex roots, which means two complex conjugated roots, which contains imaginary numbers and blah 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 blah. So its its general solution will be y is equal to e raised to px a cos omega x plus b sin omega x. So what is omega and what is b? We'll move on to that by doing three types of question. We'll move on to these three types in detail by solving three different types of questions that satisfy these three or conditions. So let's move on to the questions. So here we have the differential equation y double dash plus 5y dash plus 4y is equal to 0. So let's take out our a is equal to 5 and b is equal to 4. So we have to write the characteristic equation lambda square plus a lambda, here 5 lambda plus b is equal to 4, so 4 is equal to 0. So when we write our characteristic equation, we know how to find lambda. So lambda will be equal to, lambda is equal to minus a, which means 5, plus or minus root of a square, which means 25, minus 4b. 4 into 4, it will be 16 by 2. So we have minus 5 plus or minus root of 9 by 2, which means minus 5 plus or minus 3 by 2, and that will be lambda 1 is equal to minus 5 plus 3 by 2, which means minus 5 plus 3, that's 2, right? Minus 2, right? Minus 2 by 2 will be minus 1, and minus 5 minus 3, which means minus 8 by 2, which will be lambda 2 is equal to minus 4. So we have two lambda values. One is lambda 1 and lambda 2. Lambda 1 is equal to minus 1 and lambda 2 is equal to minus 4. So let's apply this. Lambda 1 is equal to minus 1 and lambda 2 is equal to minus 4 to our general solutions equation. So that will be equal to y is equal to, we know that y is equal to c1 e raised to lambda 1x, here minus 1 into x, which means minus x, plus c2 e raised to lambda 2x, here lambda 2 is equal to minus 4, so minus 4x. So our general solution will be y is equal to c1 e raised to negative x plus c2 e raised to negative 4x. So this is our general solution for this differential equation. So here we have real distinct roots, which means we have two values for lambda. So let's move on to another question where we handle the double root situation, where a square minus 4b is will be equal to 0. So let's try that question. So let me alter this question. So let's do this question. Y double dash plus 4y dash plus 4y is equal to 0. So here we can see that a is equal to 4 and b is equal to 4, and we have our characteristic equation lambda square plus 4 lambda plus 4 is equal to 0, and we know to find lambda we have minus a, which means minus 4, plus or minus root of a square, which means it's 16, minus 4 into 4, which means it's also 16 by 2. So here the term inside this root will be 0. So we have our lambda is equal to minus 4 by 2, which means negative 2. So here we only have one value for the lambda. So when the double root situation arises, we have to change our general solution equation. So the general solution equation for double root is y is equal to c1x plus c2 into e raised to lambda x, since we only have one lambda value for this equation. So for this situation, so when we apply the value of lambda to this equation, the general solution of this differential equation will become c1x plus c2 into e raised to lambda is equal to minus 2, so minus 2x. So here is our general solution for this equation, which is a double root situation. So let's move on to another question where we handle the complex root, which means the value inside the root, that is a square minus 4b is negative value, which means it's less than 0. So let's move on to that question and let's quickly do that. So let's quickly move on to the next session where we handle the complex conjugate root situation. So we have the differential equation y double dash plus 10y dash plus 29y is equal to 0. So here we know that we can write that a is equal to 10, so a is equal to 10 and b is equal to 29. So b is equal to 29, and we know the characteristic equation will be lambda square plus a lambda, which means 10 lambda plus b, which is equal to 29. So equal to 0. So lambda square plus 10 lambda plus 29 is equal to 0. So we know that lambda is equal to minus a, which means minus 10 plus or minus root of a square, which means it's 100, minus 4 into 29, which means it's 116, right? 116 by 2. So let's see. This is a square and this is minus 4b. So you have to understand that 4 into 29 is equal to 116. So when we do this, we have a negative. So So when we handle this situation, we have negative value inside the root. So when we have negative value inside the root, we have to use the imaginary number. So this will be equal to minus 10 plus or minus root of negative 16 by 2. So this will be 4i. So minus 10 plus 4i plus or minus 4i by 2. So we get lambda is equal to minus 5 plus or minus 2i. This will be the lambda's equation. So when we have complex conjugate root, the general solutions equation will be y is equal to, so the general solutions equation will be y is equal to e raised to px a cos omega x plus b sin omega x. So this is a cos omega x plus b sin omega x. So let me write it. So a cos omega x plus b sin omega x. So this will be our general solutions equation. So when we apply p and omega, we have lambda is equal to minus 5 plus or minus 2i. So here the 5 is the real part of this lambda and 2 is the imaginary part. So we denote the real part of this lambda as p and the imaginary part of lambda as omega. So let's see, p plus omega r. This is the general format for this kind of lambda. So we have p and omega. So let's write the general solutions equation. So y e raised to px a cos omega x plus b sin omega x. Here a and b are arbitrary constants. So let's write this p and omega in our given differential equation, which is minus 5 and 2. So the differential equation will become, so here we will have the solution as y is equal to e raised to, we have p is equal to minus 5, so e raised to minus 5x a cos omega is equal to 2, so 2x plus b sin 2x. So here we have the general solution for our differential equation, which was y double dash plus 10y dash plus 29y is equal to 0. So this is the general solution for that differential equation. So we have made up with 3 different situations for 3 different values inside the root. So the value inside the root, that is a square minus 4b, that determines what kind of general solution a differential equation with constant coefficient will get. So if the value of a square minus 4b is equal to 0, we get a double root. If it's greater than 0, we get distinct real root, and if it's less than 0, we get complex conjugate root, which means different. So we have the general solution for complex conjugate root as y is equal to e raised to px a cos omega x plus b sin omega x. So when we have distinct real root, that means the value of a square minus 4b is greater than 0, we have the general solution for the equation y is equal to c1 e raised to lambda 1x plus c2 e raised to lambda 2x. So, and when we have double root, which means the a square minus 4b term becomes 0, we have the general solutions equation as y is equal to c1x plus c2 e raised to lambda x, where there is only one lambda. So these are the 3 types of general solution for differential equations with constant coefficients. So this is my first time trying to teach a class in English, so please do bear with my mistakes and I'll improve my class. I'll definitely do. So please like, comment, share and subscribe to this channel and wait for the further contents. So bye.